class, followed by an assignment. And I have to make the assignments one at a time. So when we leave, I will stand by the door, and you can walk by one at a time, and we'll make an assignment. I'll write your name down, and you're going to write your name down. Okay? So I've got a list of some very famous engineers from history, and everybody's going to do one report themselves. Everybody has to go investigate one engineer. All right? So when you do this report, I want you to use a special format so that they all will look the same. All the reports will look the same. And then we're going to compile this into something like a book. Okay? And everybody can have that book. You can take it with you. It's something you can use forever. Electronic. So, also I want you to present your report in class. So, use Microsoft Word and okay. Okay, so here's the format. I'm going to give you a name. So you're going to, at the top of your report, in nice big letters, put the name. Okay? And then I want you to find a picture of the person. All right? It could be a photograph. If you can get a photo, but some of these people that I have are quite old, and there's no photo. So in that case, try to find a drawing. Somewhere you'll find a drawing. Ministry of Education. MOF. I can write that back later. It's okay. All right, so you're going to do this, and then you're going to have the author line. Okay, you put your name, not mine, and then put your picture. Okay. Okay, then in the main body of the report, you need to have the following information. Say when this person was born and where they were born, or, well, that's everybody's been born, of course, and then where they died, when they died and where they died, or in some cases these people are still alive, so tell where they're currently living, okay? Education. Where they went to school, what they studied, okay? When they studied, okay, where they lived, where they lived. So maybe they lived in, I don't know, in Hanoi, right? Or Bangalore, India, wherever they live. If they're still alive, say where they live now. A career summary. Where they worked. When. What some of these people, they'll have multiple interests, right? Because they, during their career, they lived and worked in different places. Okay, then, all of this stuff can be relatively short until this part. They're famous for, and here you need to describe the inventions. Inventions, discoveries, processes, patents, prizes, business, etc. Okay. And down here, I'd like you to add down here pictures. Okay, so pictures, for instance, a few of the people on this list are famous from aerospace, from the aerospace industry. So maybe you would put a picture of an airplane that they invented, right? Something like that. Or if they're famous for machinery, you put a picture of the machine. Something like that. It's up to you. And then discuss. This is a big one. Discuss the impact. What's impact? What does the word impact mean? Yeah, in general, it's like a collision, right? But when we talk about somebody's impact on the world, how did they change the world? Right? The world was going along just fine, and then this person came along, and because of what they did, the world is a little bit different today. Right? So Albert Einstein, for instance, what was his impact on the world? Yeah, his impact is enormous. For one thing, he discovered a lot of very advanced physics that previously humans didn't really understand, such as the theory of special relativity. What's the theory of special relativity? Who knows what it is? It's an amazing thing, and it's totally against intuition, I think. So everybody knows if you have a couple of, I don't know, let's say a couple of cars. Oh, perfect drawing. Beautiful. This one's going this way at B1. And over here is another one. An even better looking car. B2. When they pass each other, the relative speed one to the other should be B1 plus B2. That seems really obvious. But what did Einstein discover that we now call the theory of special relativity? This is not true at high speeds. The maximum possible speed in the universe is the speed of light. So if these two cars are both going, say, more than 1/2 the speed of light, when they pass each other, it should look like they're going past each other faster than the speed of light, but that's not possible. So even though this one could be going, say, 0.8 times the speed of light, and this one could be going 0.8 times the speed of light, when they pass each other, it's not 1.6 times the speed of light. It's maybe something like 0.9 times the speed of light. This seems impossible, but it's true. That's what Einstein discovered. He also discovered that light has mass. And that means if it passes through a gravity field, it gets acceleration from gravity, just like any other mass. Right? There's a very famous experiment. Does everybody know this story? Yeah? About the eclipse in Africa? Okay, so when Einstein first proposed that light has mass, a lot of people laughed. They said it's impossible. Okay, then came the lunar eclipse. Right? In a lunar eclipse, you have the sun and Earth. And in a lunar eclipse, the moon passes in the middle. So the light coming from the sun, some of it gets blocked by the moon and it makes a shadow on the Earth. Now, we can calculate these orbits very, very precisely. So this light that goes just past the edge, the very edge of the eclipse, we know exactly where that should happen. Exactly where that should happen. After Einstein said, light has mass, and it will bend, its trajectory will bend a little bit because of gravity, the next eclipse was in a remote part of Africa. So an expedition was mounted, and a bunch of very, very precise instruments went to that location in Africa to measure the edge. Right? And when the light came around the moon, it did bend a little bit. The instrument was precise enough it could measure that. The light really did bend. So it didn't go straight past the moon. It bends a little bit because of the moon. And missed the spot, okay? It's amazing. Now, another thing that's amazing about it is, because it was a remote part of Africa, it took a little while for the results to be reported back. It didn't happen immediately. There were no mobile phones. So Einstein got interviewed at about the time that the eclipse was happening, before the result was known. And they said, what are you going to think if it turns out you were wrong? And his answer, which is very famous, was, I think that God made a mistake, because my theory is correct. So it turned out his theory was correct. Okay, so anyway, if I were writing about Einstein, right, and I'm the author, I would say, his impact. One of his impacts was he discovered the special theory of relativity. It's an amazing thing. Another big impact of his is he was very, very important in the development of nuclear fusion. The way that we make nuclear power today, also, unfortunately, the way we make nuclear weapons. But human understanding of fusing atoms, right, splitting them and creating huge amounts of energy. I'm sorry, I'm saying fusion, I mean fission. Fission. Einstein discovered a lot about nuclear fission, which is how energy is released by dividing an atom. It's the basis of all nuclear power plants today. What we hope to make in the future, but we haven't successfully done this yet, is fusion. But what we make now is called fission. Fission is splitting. Fusion is blending them together, mashing them together. Fusion is what happens inside of stars. So in the beginning of the universe, right after the Big Bang, all matter was hydrogen. It's the first element in the periodic table. Then some hydrogen collected into big balls. This created a lot of gravity. Inside, the pressure and the temperature got so high, some of those atoms get mashed together and they become helium, the second element. And then eventually there were bigger and bigger stars and they mashed together, and now we have 100, I don't even know, 130 elements, something like that. Something like 130 elements. Most of which we can't possibly produce on Earth. We're not capable. We cannot make that high of a pressure, that high of a temperature. We don't have the capability. So those high elements that are on Earth, they all came from outer space somewhere. But we can think about fusing hydrogen into helium. Yeah. And this is what's happening in the Earth's sun right now, right? This hydrogen is turning into helium. And it happens at, who knows what rate this happens. How fast does hydrogen get turned into helium in the sun? $5 billion tons per second of that fusion goes on in the sun. And it's going to last for about approximately 11 billion years. That's a lot of hydrogen. 5 billion tons per second for 11 billion years. That's how big the sun is. And right now, we're about 4.3 billion years. So 11 billion minus 4.3, there's about 6.7 billion years left. And then the sun burns out. And then who knows what happens to Earth. It's going to disappear. Because what will happen is as the sun is burning out, it actually gets bigger. Why? Because the conversion of all this mass will slowly reduce the gravity. The gravity of the sun holds the sun itself together. The gravity is so strong it keeps it as a small ball, relatively. But as the mass gets used up, there's less gravity, and so it starts to expand. And the edge of the sun someday will be farther out into the solar system than Earth's orbit. So Earth will just get swallowed. I don't think it's going to be a problem for me. I'm pretty sure I won't be here. Maybe some of you, I don't know. If biomedicine works, who knows? Or maybe you'll be on a computer ride, like we talked about. You just keep emailing yourself to the next computer. Maybe you're still here in 6 billion years, but I'm pretty sure I'm not. Okay. So that would be a discussion of the impact. I'd like you to have a nice discussion, maybe a full page. Something serious. Not just superficial. Don't just say, he was a great guy. That's not a discussion. You could say, he was a great guy because he discovered the special theory of relativity. The special theory of relativity is very important in understanding physics. Make it a little bit longer. Okay. Is there any question about the assignment? So everybody uses the same format. Let me get this junk out of here so we see it. Everybody uses the same format so that it will look like chapters in a book, and we're going to compile it into one nice big electronic file, or you can print it if you want. And then you can have it with you always, an encyclopedia of famous engineers. And next time this class gets taught, we'll assign new names, and we'll keep adding to this book. Someday we'll have this huge book with thousands of names in it, including yours, because you're going to be one of these famous people in why. 20 years, 30 years. Okay. Are there any questions about this?
The picture we took for the dimensions, do we have to draw it?
That's up to you. Yeah. Okay, the question is about the pictures for the impact. Yeah, I think in some cases you'll be able to find photographs. In some cases you can probably find a professional artist that drew something. And maybe in some cases you can draw something yourself. That's okay. All right. I'm going to give everybody one name. Everybody gets just one name. So I want you to do a really good job with your person. Yeah. Some of them are women too. They're not all men, of course. Yeah.
So the first one and is for the writer and the other for the author.
No, for the author, the only thing I want is your name and a picture so we remember you. Next year's K46, K47, you'll be famous because your picture will be there. And for all of this stuff goes just for that guy. Okay? Yeah, all of this. The only thing for you is your name and a little picture. Okay? And make sure the picture of you is decent. Nothing dying. Okay. All right. So I'm going to stand. Maybe I wonder if it's easier if I actually stand just outside the door and come out one at a time. I'll give you a name. Be ready to write a name down. Hopefully this won't take too long. And then you're going to need to tell me your name. Write your name so I remember who's assigned to which person. Okay. I can do that too if you want. Yeah, it doesn't matter to me. Actually, it's cool in here. Why don't we do that? Okay, so, all right, let's start with Alex. Okay, Alex, here's your name. Yeah, actually, I'll tell you what we can do. I'll do it a little bit differently. This will go faster. I'm going to pass the lists around. Okay, beside each name, you write your name, the Vietnamese name, and also if you want your English nickname. Okay? So there's 4 sheets. That way you get more time to fast. One more thing. On this sheet, there's a few that I put 230 besides there. So if you're in the higher level language class, pick one of those. If you're not in the higher level language class, don't pick 230. Okay. After you put your name, if you want your read, you can go. It's a class. Yeah, just don't take too long. Make sure you write your name down. You're this side. So this class meets again. This class, engineering principles, would meet on Wednesday, not tomorrow.